Thank you very much. It's a real honor to be up here on the stage. Big thanks to all organizers from ReactiveConf. So, to start off, who am I? As mentioned, I'm Chris Laughlin, a lead UI engineer at Rapid7. We build security-based software. I work on a web application scanner, so a web app that scans web apps, which is, understandable, very meta. I have to give a shout out and a wave to my wife and my child/puppy that are watching it along with me at home. And yes, I'm a crazy person who has an Instagram for their dog, so you can follow that Instagram for cute pictures of my dog. So today I'm going to talk about NPM security, specifically around packages. We're going to look at some incidents that have happened in the past and some tools and workflows that can help us protect ourselves going forward. But to start things off, I want to kick us off with a little story, a little icebreaker to kind of get into the swing of things. So a couple of months back, I was rudely awoken at 3 a.m. Pager duty was triggering some alerts and some alarms. Our production systems were freaking out. So I quickly jumped out of bed, grabbed my phone to see what's going on. So we had a number of different issues. One, all of our Amazon instances, so our like EC2 instances, all the CPUs were at full capacity. Everything was running max. It was destroying us. We knew we were going to get a large bill. Our QA team and our customers were reporting that the site was running really slow. So when they're trying to navigate around the site, it was taking ages to load. We had third-party vendors reporting our site as vulnerable and saying that we were a malicious site that had malware on it. And we also noticed there was some strange network activity, so data was being sent off to third-party vendors we didn't work with or had any knowledge of. So I jump out of bed, grab my laptop, frankly start hacking in their system, checking things, trying to understand what's going on. So what first comes to mind is nothing's changed that I can see. Just roll back the previous build. Maybe someone's committed something and I haven't looked at the pull request yet. I build the site locally. It works fine. It works on my machine, so it must be working everywhere else. I decide to roll back our build, push back to production, and everything's the exact same. The site's still running slow, our CPUs are still high, we're getting triggered, marked as malware. I'm freaking out. Remember, it's still 3 a.m. at this point. So at that point, it's time to call quits. I take the site down, we put up a banner saying we're closed for business. I decide let's regroup with the team in the morning to see what's going on. So what happened here? So the next day we come into work, we do a deeper investigation on what was going on. We discovered that a third-party NPM package that we used to transpile code, so taking ES6/ES7 code to ES5, someone had released a new version of this with malicious code inside of it. Because our CI/CD environment always pulls in the latest patch or minor of our dependencies, we automatically got this for free. And I hadn't run an NPM install on my local machine, so I never noticed this. And as part of this, the transpiling code was reading all of our environmental variables on our CI environment, so they were able to scrape our Amazon tokens, which explains how they then got access to our Amazon account. They installed crypto miners on all of our EC2 instances, which then pushed up all the processing power. As long as this, because they were transpiling our code, they had access to the code that was being built and sent down the pipe to our customers. So they injected keyloggers into all of our forms. They also, for fun, injected a crypto miner into the site itself. So this kind of explains the data being sent off to third-party vendors and the slowness of the site. So every customer was now this huge botnet of crypto miners. And this was all done without us having any idea or any knowledge of. However, I have a confession to make. That story was completely false and made up. None of that was true. However, with the ecosystem we have at the moment and the state of NPM and security, this could have happened. It probably has happened, but it hasn't been disclosed for publicity reasons. So enough kind of scaremongering and putting the fear into people about, there's going to be people hacking your site. Let's take a look at some incidents that actually did happen. And we're going to do like a kind of little mini post-mortem on each of these instances. So we got a little timeline here of the ones that I kind of felt were significant enough to talk about. So we'll start off with a package called CrossArms. So for each of these incidents, we're going to break it down into different sections. So we're going to look at when it happened, what the impact was, what the aim of the attack was as well, the entry point for the bad actors or the hackers in this case, and then we'll also look at how we can protect ourselves from that. So CrossArms, if you're not aware of the package, it's a utility that allows you to deal with environmental variables across different environments, so whether you're on a Windows machine or a Linux machine. Quite useful. So it was the actual incident was discovered on the 2nd of August 2017, so a long time ago, but still quite relevant in this case. The impact, reasonably sized impact. We're looking at 700 downloads in total. However, the same attack, which we'll look into in a second, was carried out across 40 other different packages. The aim here, based on what the package does, is to scrape environmental variables. So kind of harken back to that story of grabbing your NPM authentication token, your AWS token, any kind of those secret private keys that you only inject into your code base as it builds. It's able to see them and send them off to their own servers. What was the entry point for this? So it was quite an interesting entry point. It was all based around typo squatting. So if you're old like me and you remember the days whenever domain names were starting to be a big thing, people would register like a site of BBC, but with 2 Cs, to trick people into going to some dodgy website that you definitely shouldn't be looking at when you're in work. And this is the same kind of thing. So there is a well-known package called cross-arms. And someone had then released a package without the dash. So people were blindly downloading, installing this package and getting the malicious code. And it's kind of that thing, like you wouldn't talk to someone and put the dash in the name. You just say CrossArms, go and install it. So how do we protect ourselves against this? So we've got two levels of protection here. Number one is check the information of the package. Do some sanity checks on where you're getting your code from. Have a look at the links on the GitHub part of the NPM site. Have a look at the author's information. Maybe look at the last release or the last commit just to see, is this a legitimate package? Is this something I can trust? I always like to use the analogy of if I sent an email to everyone in this room with a file attached that had some JavaScript in it, you wouldn't just blindly drop that into your package and release it to your users. So why would you blindly take some code from NPM and release it to your users? And then the kind of second level, this was really good, was NPM then started becoming proactive and looking to how can they up their security. So they added in name checks. So now if someone tries to package, or someone tries to release a package that has a very similar name to an existing package, it will be rejected. And you can dispute these as well, but they kind of stop this simple attack. Like if I wanted to release ReactiveConf without the dash, it would be rejected because it's such a similar name to an existing package. And then kind of moving along our time frame here, we look at another package called Event Stream. So Event Stream, again, another small utility package that helps work with node streams. In this case, found a little bit later, so the 22nd of November 2018. But then the impact kind of shifts a bit here. This is a well-known package, so we're looking at roughly 1 million weekly downloads of this package. And obviously, that's not 1 million people downloading that package. It's probably a bunch of CI, CD servers triggering this all the time. The aim here was to steal Bitcoin wallets specifically from a company called Dash Copay. And they were trying to steal this imaginary money that everyone made loads of cash out of. And I got into Bitcoin whenever the crash had happened, so I'm bitter, and that's a talk for another day, I think. But then we look at the entry point. So another kind of different entry point. A simple one was the maintainer handed over the keys to the package. So Event Stream was developed, created. The owner had built it, got it stable. Time had gone by, and they kind of shifted their focus. They changed where he was developing and where he was working. But it's still a well-known, well-used package. The bad actor in this case realized this and just simply asked, can I have full ownership of this project? I want to maintain it. I want to improve it for you. I know you don't have the time or need or want anymore. So they were able to take over this package and then do a new release with the malicious code. And because they knew the company Dash Copay were using this technology, they were able to then target them. So then when we look at the protection for this, we've got 2 levels of protection. So one is ensure that you have your packages locked down. I never did this up until recently. I always had the caret symbol on my packages, so I'd always get the patches and miners for free. But I can't be assured of what I'm getting when I'm getting them. So taking that off, locking down the specific version, using a package lock file. If you're using NPM at the minute, you're automatically getting that lock file passed in, and it's being created for you. You don't have to think about it. You don't have to worry about it. It's automatically generated. And the second one's not really a level of protection, but something that we need to think of as a community. You know, how do we own, maintain, be stewards of free open source software? And how do we continue the life cycle of that software? If you think about it, if I created an open source package today, do I have to take care of that for the rest of my life and not get paid for it? That kind of sucks. I wouldn't work in a company for free for the rest of my life, so why would I do this open source software for free? And it's kind of thinking about how we maintain that ownership, how we pass that ownership across to people, how do we deal with who owns the packages, how do we manage it? And that's something as a community we must solve. And then we move on to our last incident. So this is a package called Electron Native Notify. So again, another kind of small, easily used package. It's like a wrapper around the Electron notification system. This was discovered quite recently, so this year, 6th of June 2019. A smaller impact from the last one, 60 or 600 weekly downloads. However, the aim is where the money was in this. Again, people trying to steal this imaginary money that I'm very angry about. But working with NPM, so this is a good case where NPM were still up in their security game. They were trying to work with people on how they were getting hacked and what was going on. And it was estimated that with working with NPM, they were able to prevent $13 million US worth of cryptocurrency being stolen because they were able to intercept the wallets and then return them to the rightful owners. So it's a kind of really good success story for NPM, and it kind of proves that that small impact had a big gain. And then the entry point here is just a simple case of someone had released a minor version of a trusted package that had this code injection in it, but no one had noticed it along the way. So people were blindly taking that patch, that minor version of the code, and it was automatically updating for them. And what is our protection here? Very simple. We can see a trend here. Lock down your packages, use a package lock file. Or if you're using Yarn, use a Yarn lock file. It's the same technology, I guess. But having that lock package file, you can then assert, like, this is definitely the code that I have. Every time you do an NPM install, if you're going to get the same code, so you can always say, no matter what, this is the same code. This is what I'm giving my users. This is what I'm building. I always like to think about it, and I had the realization recently that when I release my product to my users, me and my team have probably only written about 20% of the code from that, the entire bundle that I send down the pipe. That other 80% was written by someone that I've never met, I've never seen. I don't know who they are or what they do. I just have blind faith in what they've built is one good, stable, usable, and I really pray that it's secure. And in all these cases, it isn't good people writing bad code. It's bad people injecting bad code into projects. But as developers, first nature, unless you work in a security company, your first nature is not going to be security. I'm a JavaScript developer. I'm not a security developer. I love JavaScript. I hate security. So enough kind of scaremongering stories, all these kind of things that happen. So how do we take what we're seeing and build tools and workflows to help us protect ourselves in our day-to-day work environment? We want to make things seamless. We don't want to have to think about security. We want to just get code done. So the first and probably easiest to look into is NPM Audit. If you're running on NPM CLI version 6 or above, you have this automatically. You may have noticed after you do an NPM install, it'll print out how many vulnerabilities you have in your project. I guess hands up who's run this before and had 0 vulnerabilities. If you put your hand up, put it back down, you're lying. Everyone has a vulnerability in their package. And what I really like about this, it's constantly being run all the time. It's not, and it's covering all the bases for you. So it's your dev dependencies, your bundle dependencies, your optional dependencies, it's covering everything. It has its own CLI tool built in as well, so you can do an auto fix, which will automatically try and bump packages for you. And then fix those vulnerabilities. There's some places where you may have to be intervening. I say autofix is great, but use with caution. If you're anything like me, I use an old version of some package because if I update that version, there's a break and change that I have to rewrite half of my application, and I'm a lazy developer who just wants to get stuff done. So you can kind of see this is the output. Whenever you run the audit command, it'll like list out all the vulnerabilities that you have. So you have like your moderate, the high. So this is a purposely vulnerable package I have that has an old version of jQuery in it. And you kind of get a good summary of like what was the package, what was the path to get to that package, because it's not just what you have in your project, it's also what their dependencies are too. So it goes down this very deep tree of dependency checking. And yep, we're still got there. So from this, you can then identify, look at your vulnerabilities, and then work out what you need to fix, how you need to fix it. That's all good and that's great, but you're only doing this in the command line. You're stuck in the command line. I don't always want to be in the command line. So there's another tool that I've been looking at the investigation. And I'm going to butcher the name. I was talking about this the other day. Sneak. Yes, I think it's that. So what I like about this is it's a cloud-based system. It just looks at your repositories and it can find out information. So it has like integration with source code tools such as GitHub, and I don't know any others because I only ever use GitHub. What I like about this is it can do on-demand or schedule and scan. So it's looking at your package JSON file, it's looking at your dependencies, it's trying to build out that same information that NPM Audit's doing, but it wraps up in like a pretty reports. So I have like this purposely vulnerable report or project. So I get an email every week telling me that I have vulnerabilities and I need to fix them, but I'm never going to fix them. Hopefully after this talk is done, I will then go off and fix them. And then you also get a nice dashboard where you can look at each of your different projects. So like this is kind of an example of my weekly email that I get. So I have 23, I would say, active projects. Out of these, there's 92 vulnerabilities. I get a breakdown of the high, medium, low. So I get like a good kind of overview of the health of my project, the health of what I'm building and what I'm delivering to customers. And then we can take like a detailed look into the dashboard as well. So it lists out, again, all these active projects that I'm currently working on. And they all are vulnerable for some reason. So yay for security. And you get the same information where it breaks down into different sections. And then the kind of last one we're going to look at is GitHub itself. So we're already using GitHub all the time as developers. You know, it's our source code management tool. We raise GitHub issues. We merge pull requests. We're now using GitHub Actions, so we've got our CI/CD environment in there. Why not build our vulnerability management into this existing tool? So as it says, like we have an integrated dependency checker. So they're doing the same thing again. They're looking at your package.json file, looking at your dependencies, their dependencies, and their dependencies, and trying to build up a health of your product. And it's quite cool that GitHub had recently acquired Dependabot. So now you can get automatic pull requests being created that will fix these vulnerabilities for you. So it's taken one little step out of it, and that's kind of building that workflow so we're seamlessly integrating with security and fixing our vulnerabilities. They have a really good, strong, growing database of vulnerabilities as well. So they're trying to push more, find out more vulnerabilities, build up this big list so they can safely say like what is vulnerable and what is not vulnerable. And then I like that there's kind of, it hasn't been mentioned yet from GitHub themselves, but I imagine there will be some tightly coupled integration to the package repository. So if you've ever released an NPM package before, you kind of know that I could release the package now from this machine, and that's the code that someone will get. But that doesn't necessarily mean that code lives in GitHub. So there's no real accountability between what I'm pulling from NPM and what I see on that GitHub repo. And it's the missing link between the two of those means that potentially vulnerable or malicious code can be sent to NPM and never actually make it through the GitHub pull request system. Whereas now that GitHub is hosting your source code, GitHub's hosting your package, but there's a potential to have a linkage, almost like a reverse engineer, like unpackage your code to verify what's in GitHub is in the package repository, and it builds in that accountability. So we can take a kind of a look at what you see. So this is my vulnerable project that has that jQuery vulnerability in it. And you get like a big banner saying, you are vulnerable, fix it please. And when you dig into this thing, you can kind of see the more detailed information. So this is the jQuery vulnerability. It lists out what the version that is vulnerable. It gives you some CV information. So if you're interested in your security vulnerabilities, you can dig deeper into what the CV was. There's external links to all those kind of databases. And then you have that button at the top to automatically create a pull request that will fix this vulnerability for you. So it's taking a little headache out of it. You don't have to be a security engineer. You just have to be an engineer. So kind of wrapping things up with a bit of conclusion here. So should we stop using NPM? No, of course not. It's amazing, and it's free. Hey. NPM has now become like the one-stop shop. Obviously, now that GitHub has its own package repository, that could change. But It's one of those great systems where it's constantly evolving, it's constantly growing. NPM acquired their own security team to help build out and protect users. So let's keep using NPM, let's keep encouraging, let's keep boosting that workflow. Should we start using log files? Well, if you were listening to any of the slides before, of course, yes. Log files is just the perfect way to assert that what I request from NPM is what I'm going to ship to my users. Because you can't change a previously released version on NPM, if you always request that version of code, it's the exact same code each time. And you can reason on that, and you can say, definitely, this is what I'm giving my customers, and this is what they're going to be getting. And should we think twice before using NPM packages? Yes, of course, again. Back to that analogy of I wouldn't take an email, take an attachment, and just drop that straight into my project because someone says this is a really cool way of writing functional programming or something. In the same way, we need to think about how we pull down NPM packages, how we work with NPM as an ecosystem. I hate red tape, like most people, and I don't want to have to go through a security vetting process just to get the latest version of React in my project. But it's kind of using small checks, common sense. Is it releasing too often? Has this package been around for a while? Look at the author. Look at get up stars. I guess is a good analogy for how popular something is. But those small little indicators that we need to look for when we're pulling down code and using it in our project, because that 20% we have no control over. We can control that. Sorry, the 80% we have no control over. We can control the 20%, and it's how we manage and we deal with that kind of stuff. Thank you for listening.
Don't mind me, Chris. I'm a strawberry now. So we have questions for you. Could a content security policy be a final line of defense against compromised packages in the browser?
Definitely, yes, yeah. Introducing like a content security, it will have that connection, and we'll be able to verify that this is what I'm getting, this is what I'm shipping. So yes, definitely so.
How to effectively detect malicious code injections in a project?
This is the tricky one because JavaScript's so easily manipulated and changed. A lot of the cases I've seen, it's just been someone has added a little bit of code or a post-install script. So I think it's more visual checks at the minute. I know there's some companies are looking into doing some machine learning analysis and AI looking at code to verify whether it has dodgy, malicious malware, but a lot of it's a manual process for the time.
And last question, what is your opinion about hard-coded dependencies versions?
Always hard-coded dependency versions. So that's locking them down to the version that they should be set to. I used to use the carrot and get the patches and the miners for free, but I'm also potentially getting malware for free. Yeah.
Thank you so much, everyone. This was Chris Laughlin.